right. So I'm Catherine Nakalembe. I'm an associate research professor at the University of Maryland with Hannah and Ivan. And I will just generally talk about, give an overview of how Earth observations are used in agriculture. And I'd like to start off with some big question, I guess, to kind of form the basis for where all of this started. And I wonder how many people in the room can, just a quick answer, what is food security? So we're just going back to kind of like the meaning of all of this. A quick response. Food security? Nod if you don't know. No, I saw a nod. So food security really just means that people have food at all times and are not worried about food, so they don't have to think about it. And it has many components, and these include availability, access, utilization, stability. So it's not about, I don't know, having a bunch of bad wheat and you eat that doesn't equal food security. And so agriculture monitoring is sort of the basis is basically that we want to know how much food is available where. We want to know the quality of it. You want to know if people have access to it. And it's very complex. And in terms of where we stand today regarding food security is that we're doing pretty badly. It's sort of something that is more common than you think. For example, in the US, there's food insecurity. I think approximately 2 million people in the US were food insecure in 2020. That means they're worried about, whether they'll get their food tomorrow or they can't afford what they'd like to eat. And a lot of it is sort of ingrained in people not being able to afford food rather than that there's enough food available for people to buy. And it's sometimes related to access. So there might not be markets where people are located for them to access food. And of course, this has gotten more complicated with COVID, with conflict, with more people were being displaced. We have more climatic challenges that are making more and more people food insecure. And there are several ways that we can try and address these complexities. So food security is a global problem. It's everywhere. And so the rest of my talk will basically focus on how we're using Earth observations to address some of those things related to accessibility, availability, for example. And so to know where food is or how much food is available, we have to start with a farmer. So a farmer might want to know when to plant, what might happen to their field if they plant. Will there be a disaster? Is my wheat the appropriate type of wheat for the region where I am? There are things like rainfall and temperature that in certain places are the defining factor for whether there will be food available at the end of the season or not, because farmers don't have access to irrigation. And some of the other things that you might want to look into if you're a policymaker is the potential for now, potential for the future. You might want to look into whether crops is suitable or if they will be suitable given changes that might unfold in the region. And this is where satellite data becomes really interesting. As Hannah showed, we have these satellites orbiting the Earth. Since the 70s, we've had land monitoring satellites, Landsat. What these make possible is that not only can we look back in time, but we can understand what's happening currently. And so there's some really interesting data sets that we can extract from these satellites, and Hannah will cover that in the next session. So this is sort of like a general overview of sort of how everything fits together. It's simplistic, but basically we have satellites collecting data. We use images coming from these satellites. We use machine learning to extract, information like what crop is where. So cropland, crop type. We have crop conditions. We can model yield. when you combine that with other information like rainfall, temperature, the forecasts, and whatever is going on with the soils, soil moisture, soil quality, soil, the microbiome, then you can get into more detailed things. For example, when should I fertilize? If things are really bad in terms of temperature, if it's too high, there's no rainfall, then you can talk about, well, everything's going to fail, so we need to give, a signal that things are going to be bad. And this can, help a farmer, it can help a policymaker. And since we have this broad overview of really large areas, it's really useful for policymaking. And so why Earth observations for agriculture? Pretty straightforward in a sense. We have very large areas that we have to monitor. We can't be there all the time. We have to analyze a lot of data, and in the recent years we've had huge advances in terms of capabilities. So you have not only cloud computing capabilities becoming more and more available to other people, in addition to having more and more satellite data. So being able to combine that and use it at the same time has made it possible to be able to do larger scale analyses. You can do a whole bunch of experimentation you were not able to do like 5 years ago. It can inform policies. I already talked about this. But what is really cool, I think, from my perspective, is data and methods for everywhere. So we have the same satellites, but once you start digging in, you realize you need to do a little bit more in some places than others. You may need to deal with more complex data sets, messy data, missing data. So some of if you start going back in time, you might find that there's very poor coverage of certain satellites because maybe the satellite downlink for that area didn't work. So you can't go back in time. And so just some cool pictures of how farms look like from space. An example from Kazakhstan, this is in a sort of like an alluvial fan. This is what crop fields look like there. We have an example from Saudi Arabia. This is irrigated agriculture. It's really cool because I didn't have to go there, and I can understand how fields are performing in that area. An example from the US, you can see different fields in different stages. You can see the circular ones, which are irrigated, and others that are not. And here's an example of rice in the Mekong Delta. So you can extract information about the sort of the status of rice in Vietnam without sort of physically being there, but it's a lot more complex than that. And when you put all of this together from a global perspective, you can understand, for example, where maize is growing, where wheat is growing in the summer, where wheat grows in the winter, where rice is growing, for example. And why would you want to know, the differences? Why would you want to know all of this? If there is a drought in India, in let's say, for example, this year, where a majority of our rice comes from, we might have a rice crisis on us. If there is a drought in the winter for where winter wheat comes from, that has a significant impact on wheat availability. And we all eat bread in some form, so that can have huge consequences. And so you need that kind of information and that level of detail. And so combining satellite data, cropland, crop type, vegetation conditions with things like temperature that we have access to from all over, data sets like rainfall, so precipitation, runoff, soil moisture, can help us understand how much water is available for crops, how hot it is. So certain crops have a sweet spot in terms of temperature, where you can't grow maize, for example, in Canada, or you can't grow grapes, for example, in South Sudan. And so this is really important for if you want to improve policies that might make available maybe drought-resistant wheat, or if you want to address those types of things. And combining with the fact that climate is changing, when you put all of that information together, you can better kind of assess where you might want to get food in the future. And so we can look at vegetation conditions. I don't think that's going to work, so I'm just going to skip over it. And why might this be important? So I apologize for the quality of these maps. It's not my fault. But what it's just trying to show is that the top left is where maize is grown. I believe the green one right here, if you can see my cursor. And then this is showing maize yield. And so even though there might be a lot of maize in a lot of places, maize yield is highest, for example, in the US and Europe. And if there's a drought in the US, there might be huge consequences for maize prices, for example, around the world. And we're only able to have this kind of view of this because we have satellite remote sensing. There's no other way that you'd be able to have this type of information, I believe. And so, and what would we do with it? There's quite a lot of things that we can do with having, it's, you know, a lot of power, having this type of information. I think the beginning of spying started with spying on food availability. So if you know that there is no food, for example, in a certain region, you can hike your prices so they can buy it from you, or you can just, you know, close the stores and cause a whole bunch of problems in other places. And so moving on, just to give some examples of what else we can learn, what we can do. So we can predict or understand where and when droughts are likely to happen, how severe those droughts will be, and droughts have impact not only on crops, but livestock. And one way we do that is you can combine rainfall derived from satellite data. If you combine it, well, high temperatures, that would equal very dry soils, which means no water is available for vegetation. Then you have poor conditions, which could be equivalent to drought conditions. Then you have failed crops. There's reduced food available when crops fail. And then we have food insecurity. So like you can kind of look at all of these things in sequence, but it's because you have access to all these data sets that are being collected sometimes at the same time, but in a very timely way. And then this is an example of current conditions. Generally, this is from a GLAM system. It's developed by the NASA Harvest team. And it's just showing like crop conditions globally, basically. You can see the red spots. It's really tiny, but you can see the red spots are where there might be below average conditions. And you can see that, for example, down here in Mexico and in the Midwest, everywhere that's brown is slightly below average. And so we already have too many problems going on in the world, but then having this broader view also makes you think that, oh, it could get worse, but we need to do something about it. An example from Kenya, right now in East Africa, I think this is the 4th consecutive drought affecting all of Eastern Africa. And we can look at it not only visually, looking at where the anomalies are, but we can look at it looking at time series plots where we can see where now fits within the history. So if there was a point in time, so the blue right here indicates where before the beginning of June, where crop conditions were. In some instances, it can be way worse than that. And so this is really helpful because I don't need a very fancy computer to access this information, and anybody in the world can go in and kind of look at what's going on. So my last example about the utility and the usefulness of this information is that just those simple anomalies. So this is useful because you're combining cropland. In this case, there was no crop type, actually. So we have cropland, we have vegetation conditions from the normalized difference vegetation index from the MODIS satellite, combined with rainfall, combined with temperature. There's a design, this program, the example that I'm showing was designed purely using those data sets. And with it, they were able to predict when there would be a drought. And 3 months before there would be sort of a big problem, they would make this money available, and the community would do something else rather than continue to work in their fields. And this is one example where they sort of quantify the impact of having that early warning coming from using these data sets. And over the 5 years of the program, they saved $11 million. And how they save them is this. So they still spent money on early response, But instead of reacting at the end of the season or the months when everything's going really bad, they would have a little bit of time to plan, which means they're not rushing to buy highly priced, very expensive food in emergency situations. And things move a little bit slower and there's better planning. And in a process supported over 90,000 households. I think it's approximately about 300,000 people. And so just very simple things, but simple things that are sort of founded in very good, well, one, available data available everywhere. Second, very good methods that have gotten way better than where they were at that time. We can do much more complex analyses now. In addition to working towards sort of transitioning these very sort of complex, far removed things and putting them in the hands of the people that make decisions. And so those are some of the things that are generally important in terms of transitioning from research, applied research into decision.